the demo video for our distributed operating systems project. In this project, we have made a WebSocket interface for the Twitter engine that we implemented in the project for part 1. We have got functionalities for account registration, sending tweets, tweets with hashtags and mentions, retweets, querying, and live updates. Our architecture is basically divided into 3. Our testbed acts as the client simulator, so whatever behavior the client was expected to simulate is simulated with the help of the client simulator. In the testbed, we have a pool channel which acts as the main source of communication between the client and the server. We have got the boss server which acts as a data store and it authorizes the WebSocket connection used with the help of the pool channel. So you can say that the pool channel and the boss server are together can be thought of as the JSON API, a basic program flow. The client sends a request to the pool channel to join the pool channel. Then the client sends any other request like create a user. When the client sends a create a user request to the pool channel handles it and sends a further cast to the boss server so that it can inform the boss server that a new user has been created. The boss server then sends a reply back via the pool channel to the client. Since we do not have a user interface in this to simulate our client, in this project, we will print the JSON payload which is coming back from the server to the client on the terminal. We have got 3 modules: the main boss server, we have got the pool channel, and we have got the testbed pool channel which simulates the client. So the testbed functions are for setup, random subscriptions, generating subscriptions, tweeting. We have got socket communication for tweeting, mentioning, retweeting, subscribing, logging in, logout. On the pool channel, all these requests are handled. You can see that a pool channel has handle in methods for creating users, subscribing, tweeting, mention tweets, retweeting, hashtag subscription, login, logout. When these handle in functions are called, at the same time we send cast to the gen server so that our ETS can be updated and the main server knows what data is coming in and out. So all these casts are sent to the boss module, and these casts are handled in the boss module. You can see that whenever a user is created, that is handled in the boss module. Whenever the boss module gets a tweet, gets a mention tweet, if someone wants to query or start a ZIF distribution. So the runtime commands that we have to follow in our project are run mix test -- trace. We are using -- trace so that our test doesn't time out. Let me show you how we can do this. So we are already in project 4 part 2. Otherwise, you could have done this: cd project 4 part 2 clear mix test -- trace. You can see that the user is being created. All the users are joining the pool channel right now. Now the users have started tweeting, and this is in the form of JSON. Subscriptions have started. Subscription to particular hashtags have started. Tweets with hashtags have started. Tweets with mentions have started. We can also see that our ZIF distribution has started. While this program runs, let me take you and show you the core implementation. So this is the client module, which will represent the client. If you want to change the number of clients, you have to change. You can change the number of clients out here, the number of sockets to be created. Okay, but the program will take some time. Now we can see that here we have got functions for creating tweets, mention tweets. Here we are creating random hashtags. Here we are creating mentions, logging and logout. Then we go to the pool channel. We have all the handle-ins for create user, subscribe, tweet. At the same time, we are casting it to the boss server so that our ETS can be updated. Mention tweet, retweet. At the same time, we are casting, you can see it out here, hashtag subscription. Same time, we are casting it to the boss server. When we go to the boss server has an ETS for users, hashtags, tweets, user mentions. It has a cast for created user. When the user is created, all the memory is updated. This is the computation that is going on, and then this push socket will send that the create user has been done back. This is the reply, and this is the payload that we are sending back. So this is for got tweet, and you will see that we are pushing the socket back. Push socket. Similarly, push socket. Everywhere we have a cast, we push it back. So this is as far as it goes with the code. Let me show you. This is still running, and we hope that the test case passes. While we can wait on to this, I can show you a little bit more of the project report. We see here that we have also performed ZIF distribution only for 10 nodes, and then we've plotted the graph for the ZIF distribution. This is done so that we can get the data. We see that the graph closely follows ZIF distribution. Talking about scalability, we have ran our program for 100 nodes as well as 1,000 nodes. You can change amount of the number of nodes that you want to run on the computer in the pool channel test.ex file. You would also have to make some changes if you want to see the program run quickly. You can reduce the sleep time from 1 millisecond to zero point 0.1 millisecond. It You would still be able to see the result. Here are some screenshots. And then let's go back to the test case. The test case is still running. And it passed. Thank you.